How's it going, everyone? This video is about the coefficient of variation, also known as percent standard deviation. So if you've watched the previous videos on mean value and standard deviation, or if you know what those things are, then you'll be able to understand this concept. Okay, so the mean value, okay, is a measure of what value the data points tend to be around. Okay, and that's the symbol for population mean. If you're working with a sample mean, you would use X bar, or instead of X, whatever letter you're using to represent your random variable. For standard deviation, you would use sigma for population standard deviation, or lowercase s for sample standard deviation. And what the coefficient of variation is, okay, sometimes it's just called CV, okay, that is the standard deviation divided by the mean value. And sometimes it's presented just like that, as one value divided by the other. Sometimes it's presented as a percentage, right? So you would actually multiply it by 100%. If you're working with a sample instead of the population, well, then it would be the sample standard deviation divided by the mean value. And again, you might leave it like that, or you might multiply it by 100% to put it in percent form. And that's why it's called the percent standard deviation as well as the coefficient of variation, because it's showing what the standard deviation is as a percent of the mean value. Okay, it effectively normalizes the standard deviation to the mean value. Okay, and normalizing is a tool that's used in math and science. Essentially, it's putting the standard deviation in the context of the data that you're working with, right? How widespread is the data in the context of the value that the data tends to be around? And what that tells you is whether you have a big or small standard deviation. So, for example, let's say you're looking at hours of sleep. Okay, some study looks at hours of sleep, and it turns out that in this sample, the mean value is 7, and the standard deviation is 3. Okay, now consider another study, right? Now you might think, well, is 3 a big number or a small number? Well, depends what you're talking about. If you're talking about hours of sleep, that's a pretty big number. Okay, now consider another study. Let's say it's about yearly income at some company. Okay, and what that study shows is that the sample mean is, let's say, 50,000, and the standard deviation is 3. Okay, well, the standard deviation is the same in both of these cases. Okay, but plus or minus 3 hours of sleep per night is a lot, right? Like 7 hours on average, plus or minus 3 hours, right? That's 4 hours versus 10 hours. You're a completely different person, right? Plus or minus $3 per year for someone making $50,000, that $3 isn't going to mean much, right? So you can understand that just looking at the study and understanding what it's talking about, but you can also quantify that with the coefficient of variation. So when we're talking about hours of sleep, for example, okay, your coefficient of variation is going to be 3 divided by 7 times 100%. And what that ends up being is about 43%, approximately 43%. Okay, so this standard deviation is 43% of the mean value. Okay, so how much does the data tend to vary, right? That's what the standard deviation represents. How widespread is the data? Well, the spread of the data, it's about typically 43% of the mean value. Okay, now what happens for yearly income? Okay, what's our coefficient of variation or percent standard deviation there? Well, it's going to be 3 over 50,000 times 100%. And what that gives us is 0.006%. Okay, if you were to round that to one decimal point, it's just 0. All right. So a standard deviation of 3 versus a standard deviation of 3, well, you kind of have to maybe scratch your head a little bit to decide what's bigger. I mean, they are the same value, but what of the two cases means more widespread data? Well, you have to scratch your head about it. But if you look at something where they're both normalized to their mean value, right? You don't even have to know that one is hours of sleep and the other is yearly income. You could just look at this and be like, okay, in one case, the standard deviation is 43% of the mean value, which is quite a bit of variation. And in the other case, it's 0.006% of the mean value, which is pretty much no variation at all. Okay, so that's the usefulness of the coefficient of variation, also known as percent standard deviation. It lets you know whether in the context of the data points that you're working with, whether the variation in the data is big or small. So that's a useful tool to have. And if you haven't seen the videos on mean value and standard deviation, I'm going to put the links to those in the description of this video. So hope you enjoyed that, and see you next time.